This question says an object of mass 6 kilograms is whirled round in a vertical circle of radius 2 meters with an angular velocity of 4 radians per second. Calculate the maximum and minimum tension in the string connecting the object to the center of the circle. So as ever with things going in a vertical circle, when it's at the top, we expect its weight to be acting down towards the center of the circle, us to get some additional tension from the string. And so at the top, we expect the weight plus the tension to be equal to the centripetal force. I'm going to write that down as m omega squared r, since we've been given an angular velocity. At the bottom, the weight will still be acting down. The tension will be acting up, and therefore the tension minus the weight will have to be equal to m omega squared r. So we've got this minimum value of tension and maximum value of tension that we want to find. So the minimum value is equal to m omega squared r minus w, which in this case is 6 kilograms times 4 radians per second squared times 2 meters. Take away the weight, which is the weight, which is 6.0 times 9.81. So I'm going to calculate that. That's 133 newtons. Two significant figures should be enough for what we're doing here, shouldn't it? So 130 newtons, and the maximum tension is equal to m omega squared r plus w. So from the value I've just calculated, I need to add the weight back in twice, don't I? Sorry, take the weight away twice. Sorry, let's just do it from scratch. 6 times 4 squared times 2 plus 6 times 9.81 is 251, but we're going to round it to 250 newtons. So we've got our minimum and a maximum force. The string breaks when the tension exceeds 360 newtons. Sorry, we're on part B. The string breaks when the tension exceeds 360 newtons. Calculate the maximum angular velocity and state where the object will be when the string breaks. Well, if the thing speeds up slowly, we already worked out the maximum force is when it's at the bottom. So let's get that bit out of the way first. Breaks at bottom. That's when the tension is biggest. Then, so we're looking at this bottom half of the equation where we know T max minus W is equal to m omega squared r. We're trying to find the maximum angular velocity omega, so we're going to rearrange this for omega. Omega is T max minus W over m r square rooted. So that's the square root of 360 minus 6 times 9.81 over 6 times 2. Let's do that calculation. That's 5, so 5.0 radians per second.